Safety switches, the high and low of it. One of the main calls that we get about safety switches is there a Schrader valve behind the safety switch? On most threaded high pressure or low pressure safety switches, there usually is not a Schrader valve behind them. But some safety switches have a Schrader core depressor in them, and some manufacturers do put Schrader cores behind their safety switches. But usually the ones that are brazed on do not have a Schrader valve behind them. So when you have a high or low pressure switch that you need to replace, it's safe to assume that usually they will not have a Schrader valve behind them. The most common switches that you have on an air conditioner or heat pump is a high pressure switch and a low pressure switch. And as you note, these are brazed on type. And as we stated before, usually these do not have a Schrader core behind them. So in order to replace these switches, you would have to recover the refrigerant and then replace the switch and then recharge the system after the repair is accomplished. When you have a high or low pressure trip, the first thing you want to do in troubleshooting the situation is to check the high pressure or low pressure switch to see whether it is open or closed. You would do this by tracing the wires to where they connect to the control board and testing the switch to make sure that it's open or closed. In following a wiring diagram for pressure switches, you notice that our low and high pressure switch in this diagram is in series, and if either one of these switches were to open, it would shut down the compressor. So not only do you want to check the switch itself, but you also want to check the wiring. Many times a technician will say the switch is closed and the compressor should be operating, but there's a break in the wire or where it is connected to the control board. So make sure you check the entire circuit and make sure there is no break in the wiring of the low or high pressure switch back to the control board. In this other example, this is on a commercial unit where we have a high and low pressure for circuit 1 and a high and low pressure for circuit 2. The same thing applies here. Follow the wiring back to the control board and make sure that you do not have an open wire or a loose connection. In this diagram, we once again have our safeties. We have a discharge temperature safety, we have a high pressure switch, and we have a low pressure switch, all of which are in series with the contactor coil. Also in this diagram, we have what is called a CLO, or a compressor lockout relay. If any of the pressure switches on this system were to open, it would de-energize this contact in the compressor lockout relay, and it would energize this contact, which is designed to send a signal back to a thermostat that would illuminate an LED and tell you the system is in a lockout condition. So when you're troubleshooting high pressure, low pressure, discharge safety, or any safeties in a system, you need to do a hopscotch method and trace back the wiring to find out where you're losing the voltage and why the system is locked out.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.